Yo guys, what's up? This is Scummers from MenuDocs, coming back at you again with another episode of Intro to Py. Today it's episode 3, and we're going to be covering some string things on escape characters, indexing into strings, as well as some logical stuff like plus, minus, and all of that jazz. So I've just got a command window opened up for us with Python 3.8.5, and we're just going to go ahead and make a string. Let's say hello. Some nice things we can do. If you remember last episode, we showed you that you can index into lists using square brackets. Now we can do the same thing with strings. So if we go x0, you notice that it returns h. And then if we go len of x, it'll return the length of that string, which is 5. And that's quite cool. And now we've got another nice thing that we want to do here, which you can use on, lists. You can use on any sort of sequence of collection, sequence, list of anything you want. So string, we've got like a list of characters, so to work on that you can do it on a list as well. I'll show you that in a bit. So if we go x and then we go square brackets, and then let's say we put a colon and then a 2, it can be any number, press enter. So that's going to return the first 2 items. So we see here it goes, colon is basically saying cool, okay, we've got a split in here. And then the 2 is going, cool, the 2 is on the right side of the colon. That means that I want everything up until this index. So we go 1, and then we go 2. So we get those first 2 items there, H, E. And then if we go X like this, and then we go 2, like so, it's going to go ahead and go, okay, it's on the left hand side, which means I want everything after this. So we're going to go 1, 2, ignore those, and then we want everything after that second item, so it's going to go 1, 2, 3. Press enter a couple times, and you can do that with lists as well. So if we go C equals 1, 2, 3. So if we go C2, see that it returns 3, and if we go C2, it'll return 1 and 2 because that's the first 2 items. Now there's another cool thing we can do here as well, which is with negative numbers. So if I go like this, what do you think it's going to do? So it returns hello. Well, hello. Because it goes -2. Okay, I want everything up until -2. So -2 just means we start counting from the right hand side. So up here we count from the start, so we go 1, 2. The negative goes, okay, we start at the back, and then we're going to go 1, 2, and so we want everything before that, which is HEL. And that's just a cool feature of that, and we can do that with our lists as well. Not sure how well it's going to work here. That should get the last item. Last 2 items. And then what I was saying about last item is if you get rid of the colon, you can index it using negative numbers. So if I want E and hello, we can go 1, or we can go and you can index it with negative items like that, and it's quite cool. And that's just some nice string stuff that we're going to do. Anyway, now we've got another thing I want to cover, and we're not going to dive into it too much, but that is the backslash. So if I just go ahead and figure out how to clear this terminal, I don't know how to clear this terminal, so I'm just going to press enter a few times.
Today's video is proudly powered by our partner, Oxide Hosting. Get your products hosted by them with their cheap, reliable services. So what are you waiting for? Check them out in the description below.
And basically what we're just going to be doing now is showing you what it means. So if we go ahead and we make a string with 2 quotes, it's an empty string. But what happens if I want to put a 3rd quote in there? It's not going to work because it expects another quote here. We're going to control C that. But it's saying, invalid while scanning triple quoted string loadable. Because what we want is we need Python not to treat it as an opening or closing quote, but to just treat it as a regular quote. So we could go, single quote, double quote, single quote, that'll work. But we're going to use all double quotes, and then if we put a backslash in it, the backslash goes to Python and says, hey look man, whatever character comes straight after this, treat it kind of normally. It's a special character, but I've got a backslash in front of it, which means you're going to treat it, not as whatever you'd think it is normally, but as just a regular quotation mark. So if we go 1, backslash 1, boom, it just treats it normally. And now you might be wondering, what happens if I put a backslash in? Well, the backslash ignores the character after it. So it's ignored our closing quotation mark. So what we want to do there is we need to backslash a backslash. And that's kind of cool. It's kind of annoying in practice, but there are ways around that, but it's just something to make note of. But the best thing you're probably going to learn is what \n stands for. You'll use this a lot, and \n gives you a new line character. So if we go like this and then we go hello \n world, it's not going to do anything now because the Python interpreter is just spitting it out as a raw value. But if we try print z, then it will go and it will render it. So it will render out those special characters, and that's also why we've got stuff like this. So if we go print bam, 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 it'll get rid of that quote. It's just that when you're using the Python thing here, the interpreter will go, cool, okay, what's the raw value? What is the value using wrapper? Which gives you the exact value, whereas what we want when we're printing it and using it is the string version of that. So you notice if we print it, it prints out, gets rid of that. If we print this here, it evaluates the \n, it goes, okay, hello, I'm going to print hello, oh, there's a backslash here. What's next in n? Okay, I, as a computer, know that stands for a Newline character. So it goes off and it prints Newline characters, and then it goes, okay, world, end of string, okay, I'll just print world. But that's basically that with regard to strings, and you can use that on anything. Newline characters are really useful, you'll probably use them a lot. But let's just dive into showing you some of the things that we can use in Python. So we're going to go ahead, open up a new window, go Python, and this is just going to be logical stuff. I'm not going to spend a lot of time on it, because you should know what most of these are. I just want to show you that they exist in Python, so you can go 1 plus 1 is 2, 1 minus 1 is 0, 2 times 2 is 4, and then if we want to square it, okay, we'll go 3 times 3 here, so you get 9, but if we want to square that or put it to the power of, we use 2 asterisks, and then that will put it to the power of, so 3 to the power of 3, rather than, 3 divided by 3. Anyway, if we go, 3 divided by 3, we'll get 1.0, and then if we go 5 divided by 3, we'll get 1.667. But if we want to, have that regular number, we can do 5//3, and that will round down, so that's floor division. And then if we want to get the remainder, it's 5 modulo 3, and that'll tell you how many is left over. So 5 goes into 3 one time, and then there's 2 remainder. And there's a nice function called divmod, which we can give it 5 and we can give it 3, and that'll return saying it goes in one time, and then there is 2 left over. So that's quite cool, and something nice to keep in mind. There is also something to note with computers, is that floating point numbers, which are these here with decimals, so decimal numbers can't be represented entirely accurate. So 1.000, as many zeros as you could possibly fit, and then a 1. You'd think it'd be accurate, it'd round down to 1, but computers can't replicate things exactly in memory just because of how the system works. So like 1/3, or I don't know if this will work, 1/3, 0.3233, and that'll go on forever because it doesn't understand how to make that an exact item. That's okay, you probably won't run into issues with it too much, but it's just something to note that on some edge cases when you're attempting to do some like really precise math, programming trips up with floating point numbers. So at that point, you might just want to use whole numbers and then convert them. So say if you're dealing with money, rather than having your cents as a .80 cents, you'd have a number variable which is say 80, and then you could do like 80 minus 20, which would be 80 cents minus 20 cents. And then when you show it to the user, you just render it with a dot in front of it. And that's how they know that it's cents. And that makes it just a bit more accurate, but you don't really have to worry about that, considering this is just an intro course. And another cool thing that we can do is Python supports bedmass. So if we add brackets, if we go 1, 2 times 3, so 2 times 3 is 6, plus 1 is 7, right? But if we go in brackets 1 plus 2 times 3, this will give us 9. The brackets just mean, hey, do me first. So this one here, it goes, okay, there's a plus and there's a times. We do the times first, and then we'll do the plus. This goes, hey, there's some brackets here. We'll do the brackets first, and then we'll do the times. But this is, just math stuff. So we're not going to cover it too much. I'm just sort of showing you that it exists. And then we've also got some more stuff like greater than or less than. So we can go 2 bigger than 1 is true, or we can go 1 bigger than 2. And well, that's false. But hey, we can flip that around. We can go 1 less than 2. It's true. But is 2 less than 1? No, that's not true. What about 1 less than 1? That's false. What about 1 less than equal to 1? That's true. 1 bigger than equal to 1? That's also true. What about is 1 1? Cool. 1 equal to? No. So it's just, you've got all these nice checks, and these are just comparison operators. So they return true or false. So true if the statement is true. So is 2 bigger than 1? Yes. Is 1 bigger than 2? No. And we'll dive into that more next episode when we go into sort of if statements and how we use these truthy falsy values. But for now, you don't have to worry about them too much. And now we've got a nice other one called is. Is refers to actual, like in-memory location. So is it physically 1? So we go x equals 1, c equals 1, x equals c is true, but x is c. That's also true. Because if we go the ID of x is equal to the ID of c, so they're true. ID is just a convenient way to get a memory location, by the way. You'll notice that it returns the same. Why this is true is because Python preloads the numbers -5 up to 254, I believe it is, into memory. So they all cache and they use the same memory address. But if we go like d is equal to 1, 2, 3, 4, 5, and then y is equal to 1, 2, 3, 4, 5, I don't quite think that'll return true because they've put them into different locations. So we've got ID, y. You notice that it showed up in a different location. But you don't really have to worry about that too much until later on. We'll dive into this in the if statement next episode, about how we compare things to none and false versus how we check things for equality. And just another thing to note with equality is that also checks types. So you remember from last episode we had things like integers and strings. So if we try to compare these two together, it will return false, because a 1 is also a number. The one on the left, this is the number 1. The one on the right, this is a string representing 1. So they're two different things. So that's something to keep in mind, is that we just want to, just make sure that what we're checking against is actually the same type as well. Otherwise, it's not going to return true. And I did show you a little bit of this in the last episode, but there's also another one called in. So we can go 1 in, and then we'll go range 1 to 4. So the range function just lets us create a list. So if we go 55, it'll just create a list from 1 to 55, but it's exclusive of this last item. So it's just a shortcut we're using to make a list. But in checks if the thing on the left is within the collection or list on the right. It doesn't have to be a list, it can be a dictionary, it can be a custom data structure. But dive into that in a later episode, and for now, I think that's enough. I hope you guys have enjoyed, and I will see you in the next episode.